Okay, go to assignment 5.8. Try problem number 1. Pause this video right now, and then when you get done, go ahead and hit play, and then we'll do problem 1. Okay, one straightforward, just using the equation, right? You've got how much energy? We're talking about kinetic energy of rotation, which is equal to 1/2 I omega squared. So that'd be 1/2. The inertia I give you for the problem is 200. 200. The velocity is 3 radians per second squared. Put in my calculator, I get 900 joules, and I'm done with that problem. Go ahead and try problem number 2. Again, when you get done, unpause it, and we will take a look. As a hint, you should not take very long doing that problem. All right, problem number 2. Problem number 2. Here's my pen. Here's my pen. Problem number 2. Problem number 2 is if the boat wheel were slowed to a stop by coming in contact with a surface, how much heat would it make? Well, it has 200 joules of energy, right? Where did it all go? It all went to heat. So the answer is 900 joules. And we are done. Go ahead and try problem number 3. We'll do problem number 3, and then I'll show you the answer to number 3. And then we'll do 4 and 5 afterwards in just a moment. So let's try problem number 3. Go ahead and pause it, and then start it up again when you're ready to do problem number 3. All right, problem number 3. Montezuma's Revenge is a ride with a train of mass 12,100 kilograms is shot from 0 to 30 meters per second in 4 seconds. It's propelled by a large inertia of 60,500 kilogram meter squared wheel. How fast would the wheel need to be moving if it comes to rest after launching the train? So we have another situation where we have energy before equals energy after. Okay, the energy before in this case would be equal to kinetic energy, but it's kinetic energy rotational. Now we're going to turn it all into kinetic energy, normal kinetic energy, right? So the wheel is spinning underneath. We drop the train on it. That stops the wheel but launches the vehicle. Okay. So we look at this and go, okay, so kinetic energy rotational would look something like 1/2 I omega squared is equal to 1/2 mv squared. So I get 1/2 inertia. Inertia for the wheel is 60,500. And it's we want to know how fast we need to be going. So omega squared equals 1/2 the mass of the train. I want to make the train, which is 12,100 kilograms, go a speed of 30 meters per second squared. Now, you might have thought, okay, I need to put some kinetic energy over here, which is okay, but initial velocity is 0, right? So that's kinetic energy is going to be 0, so it's going to fall off. Okay. All right, so then it's just a matter of putting it on my calculator here to equal. And so I'm going to get 0.5 times 12,100 times 30 squared. All right, and then I'm going to multiply by 2 to get that thing across. And I'm going to divide by 60,500, and I get a whopping, it needs to be going 180 radians per second to make the car go that fast. Okay, with that in mind, go ahead and try problems 4 and then try problem number 5. So one thing that tricked people is 4 and 5 are related, even though it says problem number 4 and problem number 5. They are related to each other. So try this out, and I will get back to you in just a moment. Go ahead and pause it. All right, problem number 4 should be pretty trivial. 1/2 I omega squared, right? Plug in all the numbers, get out your answer. That's groovy, all right? Go ahead and check your answer for number 4. If your answer is wrong for number 4, fix your answer to number 5. If your answer is not wrong, you don't even have to pause. I'll be doing the next part in just a moment. All right, problem number 5 is a little weird to understand. You've got a flywheel spinning, right? And it's this one here, right, from the previous problem. And then somebody throws in, so you got a pallet of bricks on the ground. A bunch of bricks up there. They throw a rope over the top of it, and it gets caught in the flywheel. So it keeps spinning, but it's actually lifting up the bricks, right? Which takes energy. So we go, well, energy before equals energy after. Before the problem begins, I've got a kinetic energy for rotation. After the energy, I have potential energy. It says that the wheel comes to a stop. So this thing's actually going to reel up the bricks, and then the bricks are going to get to a certain height. And probably what happened actually is the bricks would come right back down, the wheel would start spinning the other way with the same energy. But that's not what the question even asks about, so we won't do that at all. So I know I've got 3,250,000 joules over here because I solved it in the previous problem. That's equal to mgh, right? So mgh, what's the mass of the bricks? That's what I want to know. What is the acceleration due to gravity? Well, we hope we're on planet Earth. That's where bricks usually are. And then the height is 4 meters. So I plug in 3,250, 1, 2, 3. And then 3,250 divided by 4 divided by 9.8. And I get the mass of bricks would be tremendous. This is a big stack of bricks. So I've got a mass is equal to 82,900 kilograms. A large pallet of bricks. Okay? All right, finish the rest of the problems. You should be good to go. There shouldn't be anything else that throws you off. Okay.